Okay, this video we're going to be talking about the zeros of the quadratic equations. So again, quadratic equations are the y equals ax squared plus bx plus c. So it's when we have an x squared in the problem, it's going to make that parabola. Okay, so first off, zero product property. If ab equals 0, then that means a would equal 0 and b would also equal 0. Okay, so this represents my a and my b. So what I can do is figure out the values that would make those 0. So if I add 3 here, I get x equals 3. If I subtract 2, I get x equals negative 2. So if I plug this in, negative 2 plus 2 is 0, so that would make my a 0. If I plug this 3 in, 3 minus 3 is 0, that would make my b 0. So you're setting both of those equal to 0 to figure out what numbers would make my a and b 0. Okay, zeros of the function is where it's going to be crossing your x-axis. So if I had this graph, my 0 would be here and here. So my 0 would be negative 4. So it would be negative 4, 0, and then it would also be 1, 2, 3, 0. So we're going to be finding where it's crossing those spots on our axis. Okay, so here is our general form of a quadratic equation. You know you're trying to find your zeros when it's equal to 0. So you're going to be doing that extra work, okay? So we need to get it into a form where we can use ZPP. So we need to factor it. Okay, so what multiplies to get me 8, but adds to get me 6, well 4 and 2 do. So we would write it x plus 4 x plus 2 equals 0. Now we can do our ZPP, so x plus 4 equals 0. And x plus 2 equals 0. So subtract 2, so x is equal to negative 2. So negative 2 zeros one x-intercept if I graph this. And we subtract 4, x is equal to negative 4. So negative 4, 0 would be my other x-intercept if I graph this. Okay, this one I need to get it to be equal to 0 so I can factor it. So I need to move this over here by subtracting it. And then I want to make sure I put it in standard form. So I got x squared minus 9x plus 18 equals 0 to put it in that standard form. So it multiplies to get me 18 but adds to get negative 9. Negative 6 and negative 3 does. So I'd write x minus 6, x minus 3. Now we can do our ZPP, so x minus 6 equals 0, x minus 3 equals 0. We add 3. We add 6. So that means I'd have one x-intercept at 6, 0 and my other x-intercept at 3, 0. So it'd be intercepting my axis at those two spots if I were to graph it. Okay, we got to get this 3 over to get it into standard form. So I'm going to subtract it and make sure I put it in standard form. So 2x squared minus x minus 3 equals 0. This one I can't see what multiplies to give me negative 3 adds to get negative 1 because I have this number back here that I need to send back. Whenever there's a number in front of x squared, you got to remember to send it back. So what multiplies to get me 6 adds to get negative 1. You could do negative 3 and 2. So x minus 3, x plus 2. But we sent a 2 back by multiplying, so we need to undo that and divide by 2. So now I have this x minus 3 over 2. And this x plus 1. So if I do ZPP, I could bring this bottom up, but since ZPP you're going to be solving for x anyways, you could just set that equal to 0 and set this equal to 0 and do a lot less work. So if I subtract 1, I got negative 1, 0. And if I add 3 over 2, I get 3 over 2, 0. So that's where I'd be crossing my x-axis for this one. Okay, this one, it looks like what multiplies to get me 0 but adds to give me negative 4, there isn't anything, but if you look, they both have something in common. They both have an x that we could pull out as a GCF. So if I pull that x out, I divide both of them by x and put it on the outside. X squared divided by x is just x. 4x divided by x is just 4. Now this is the same thing as if I wanted to write x minus 0. Okay, it means the exact same thing. So we're going to do the same thing that we have been doing with my ZPP and set it equal to 0. So x minus 0 equals 0. X minus 4 equals 0. That cancels, so it's just x equals 0. So you're basically taking this and setting it equal to 0. And this one, if we add 4, we get x is equal to 4. So we got 4, 0 and 0, 0. So you got to make sure that you're looking for GCF in these as well. Okay, so first off, is there a GCF? It doesn't look like they have anything in common, so let's go ahead and send this negative 5 back. So I got x squared minus 3x minus 40 equals 0. So what multiplies to get me negative 40 and multiplies to give me negative 40, adds to give me negative 3. So negative 8, come on, negative 8 and positive 5. So I got x minus 8, x plus 5, but we need to undo what we sent back, so divide both by negative 5. And simplify if we can. 2 negatives make a positive, so this becomes 8 over 5. And this becomes x minus 1. It's still set equal to 0, or that little surprise face. So we got to set these both equal to 0, so x plus 8 over 5 equals 0, x minus 1 equals 0. So we'd add 1. So our first one is going to be 1, 0. We subtract 8 over 5. So our second one is negative 8 over 5, 0. Okay, doesn't look like we have a GCF, but we need to send this 3 back by multiplying. So I would get x squared plus 4x minus 12. So what multiplies to get me negative 12 adds to get 4. So we could do positive 6 and negative 2. We would rewrite it x plus 6, x minus 2. We need to undo that 3 we sent back, so divide by 3. So we got x plus 2, and this x minus 2 over 3. If we set them both equal to 0, we should get 2/3, 0, and we get negative 2, 0. Okay, this one it looks like we have a GCF. It looks like they both share a 2 and an x, so let's divide by 2x. Remember that goes on the outside. 6 divided by 2 is 3, x squared divided by x is x, 4 divided by 2 is 2. We set them both equal to 0 like we did in the other one, so 2x equals 0, and 3x plus 2 equals 0, so we got to subtract 2, divide by 3. So we got negative 2/3, 0. If I divide by 2, I got x is equal to 0, so my other one is 0, 0. Okay, let's get it in standard form, so let's go ahead and get that 8x over, so subtract it. So I have 2x squared minus 8x is equal to 0. Gosh. Okay, they have a GCF, so let's go ahead and divide both by 2x. Put it on the outside, so I get x minus 4. Set them both equal to 0. So the right side one, if we add 4, we should get 4, 0. If we divide by 2, we get 0, 0. So that's where it would be crossing my x-axis at. Okay, if you wanted to use a graphing calculator to solve it, you would plug into your graphing calculator y equals x squared plus 5x plus 3. You would see your graph, and then you would have to go into the intercepts mode. So you would have to first put that into your calculator, and then you would have to press the graph button, and then you would have to press the second button, and then the button that's going to say trace, but what we're really looking for is the calc that's on top of it. So once you press that, it'll pop up a bunch of things that say calculate. You press number 2 because you're trying to find the zeros. Then it will say left bound, so you want to go to the right of the 0 you're trying to find, and then once you go to the left of it, you click enter, and then it will say right bound. So you go to the right of the 0 you're trying to find, and you will press enter. And then the next point you want to try to get really close to where that 0 is, and then you will press enter again. And then it will tell you that exact point of where it's at. So this one's at negative 0.6970. Okay, so that's the right one. Now you have to do the left one because there's two of them. Whenever you do quadratics, that's why it's a squared. So you'd have to do the exact same thing to find the other one.